All right. So first of all, thank you very much for inviting me to talk today about climate risk and asset prices. Um, so um, Financial markets play a very important role in both managing and addressing climate risks. And for example, the mitigation side, they help channel resources from polluting investment to green investment and green energy sources. And as another example, on the adaptation side, they help investors share climate risk globally and also finance adaptation solutions. Now, a necessary condition for all this to work is that prices in financial markets properly reflect climate risk exposures. And that's an important kind of empirical question. And there's been several recent papers that have been exploring in the data whether that's true in different markets. So today, I want to focus on two important markets, the real estate market and stock market, both of which I've explored in various papers with various co-authors. So let me start with real estate. Now, real estate is, first of all, a very, very important asset just because, so many people have a large part of their wealth in real estate. But from the point of view of climate risk, it's a particularly interesting asset to study because it's so inextricably linked to location. And of course, location is itself an important determinant of climate risk exposures, especially physical risk like flooding and hurricanes and wildfires and importantly, rising sea levels. So understanding whether climate risk is priced in real estate market is important. That's a great asset class to study. And when we start thinking about how to test whether climate change is indeed reflected in house prices, well, the first kind of crucial question is a measurement issue, which is how do we identify which houses are exposed to climate risk and which are not, and measure the intensity, how exposed they are. So in our paper, we take a first stab at this. And what we do is we look at 4 coastal states in the US, and we geocode all the transactions of houses that occur, of which we observe many characteristics as well as the price. And we merge the geocoded information with NOAA maps on the predicted areas of 6 feet sea level rise. Okay, so the idea is basically we're trying to distinguish between those houses that, if the sea level rises by 6 feet or more, those that by 6 feet, those that are exposed and those that are not exposed. Now, here's an example of downtown Miami. So you can see a bunch of green dots and red dots. Here, the green dots are those houses that are not exposed to the 6 feet sea level rise, and the red dots are those that are exposed. Okay, and so in some sense, what we really would like to understand is, what is the price difference between the houses that are exposed, the red houses versus the green houses? Are they cheaper because of climate risk exposure? Now, the kind of most immediate way to do this, to study this, would be to compare, to simply compare the prices of the red houses and the prices of the green houses. But of course, there's a problem, which is that these two sets of houses, they differ in different dimensions. For example, the red houses tend to be, as you can see from the map, they tend to be right on the beach. And of course, they're kind of more valuable for other reasons, for their kind of amenity value of being on the beach. So we cannot really do a proper kind of direct comparison between the price of the green house and the price of the red houses. What we can do, however, is we can try to do a difference in difference. And with that approach, try to identify the role of climate risk in determining house prices. So how do we do that? So for every zip code and quarter, we compute a measure of attention to climate change. And how do we do it? We look at all the real estate listings in that quarter, in that zip code, and we count what fraction mentions climate-related issues. So here's an example of a real estate listing that we count as, talking about climate change issues. So it's a down in the rough on water with pier and dock. Owner holds letter of exemption from FEMA stating high elevation and flood insurance perhaps not required. So you can see that clearly the real estate listing directly talks about climate issues. We count for in every location and every point in time how many of the listings are actually kind of talking directly about climate change, and we produce a measure of climate change attention that varies across zip codes and over time. And the idea, what is the idea here? The idea is we're not going to compare the level of houses that are exposed to climate risk and not exposed to climate risk, because that is confounding effects. But rather, we're going to ask how the relative prices change after people become more attentive to climate risk. And what do we find? We find that indeed in periods and in areas where people pay more attention to climate risk, the prices of those houses that are exposed to climate risk, they drop by more than the prices of those houses that are not exposed to climate risk. Okay, and so what we conclude? We conclude the climate risk is indeed priced in real estate. Now, that's true for houses. What about stocks, which is, of course, another very important asset class? Well, here in a different paper, we do a very similar exercise in that we are basically using environmental scores produced by some commercial data sets to measure which firms are exposed to climate risk and which firms are not exposed to climate risk. And so we now have a classification of firms exposed and not exposed. And then again, we're going to use a climate attention measure. And in this case, what do? We look at the historical data on the Wall Street Journal, on the entire text of the Wall Street Journal, and we compare the text of the Wall Street Journal with some climate vocabularies to figure out, basically how intensely in any particular day the Wall Street Journal is talking about climate change. And so we're going to build a measure basically of climate attention in the Wall Street Journal, which is a measure that should be relevant to investors because it comes from Wall Street Journal text. And we really build two measures. One of them is simply how much the Wall Street Journal talks about climate change. And a second measure, which is adjusted by sentiment, that says whether we're getting good news or bad news about climate change. And we therefore then combine our climate attention measure with the exposures of firms to climate risk measured by the E-scores. And again, to do this different analysis to try to understand how different firms react to more or less attention to climate risk. And very similar to what we find for the housing market, in the stock market, we indeed find that firms with high environmental scores outperform in periods with negative news about climate change. So what does it mean? Again, that as investors become more worried about climate change, or there's more bad news about climate change, indeed, stocks with high E-scores do better than stocks with low E-scores. So again, that's direct evidence that climate risk is priced in the equity market. Now, in this paper, we actually go one step forward and we say, okay, how can we use this information to actually build effectively insurance against climate risk? So the idea is very simple, that if you build a portfolio, a long-short portfolio, that is based on these E-scores, you can actually hedge climate risk. If you go long firms with high E-scores and short firms with low E-scores within each industry, you can actually, your portfolio is going to do well when there's bad news in climate change, and it's going to do badly when there's bad news, good news with climate change, which basically is what insurance does. Okay, so we can use equity markets, which are very accessible, to build insurance targeted to hedging climate risks. Now, let me just conclude. So the broad body of evidence we have so far, including these two papers, suggests that climate risks are indeed reflected in asset markets, which is a good sign about the ability of our financial markets to help solve the climate crisis. Now, of course, these are just first steps, and there's a lot more work to be done in many directions. So first of all, it's important that we understand not just whether climate risks are incorporated, but also whether it's really fully and correctly incorporated. So in a sense, how efficient are markets in incorporating these risks? That's something we don't still have a good answer to, but it's important to figure out in order to make sure markets work, financial markets work at their best. Second, right now, we have to, in a sense, build our own measure of exposures. For housing markets, we use some information about the sea-level exposures. For stocks, we used information about some E-scores, but it's not clear those are the best potential measures. So I think there's a lot more work to do into figuring out exactly what are the best measures of climate exposures, and also maybe to figure out what, for different aspects of climate risk or different types of climate risks, what are the best measures of exposure. That's a lot more work needs to be done on that front. And finally, more kind of the broader level, one of the things we show in our paper on the stock market is that it's actually very difficult to hedge well climate risks using just equities. You can go some way, but it's difficult to really hedge them very well. And so there's room for a better design of assets, for example, derivatives that are targeted specifically to hedge climate risk. So, it's an exciting field, it's an important research field, and, I'm looking forward to what the future work.